This video was brought to you by Indently.io, learning Python made simple.
How's it going, everyone? In today's video, we're going to be going over 5 good Python practices that I recommend you follow when you are programming in Python. Starting with good practice number 1, naming. In Python and most programming languages, you're going to always want to give your variables both descriptive and concise names at the same time. But let's look at some good and bad cases. A good case would be having a name of type string, which is equal to Bob, which has an age of type integer, which is equal to 29. These variable names are fine. They are descriptive and they go straight to the point. What you shouldn't do is type in n of type string is equal to Bob. N is not a descriptive name and will always require you to actually read and kind of decipher for yourself what it is. And the same thing goes for a. Do not name it a and say of type int is equal to 29. This is not descriptive enough. It requires you either to add comments or to add some sort of note or to read through your code to find out what it actually does. And once again, it's good to be descriptive, but you also want to keep it concise. For example, you might be creating a game. So start score of type integer, which is set to 0, is a perfect variable name. It gives us just enough information to understand what it is. Typing in score that the user starts with at the beginning of the game of type integer is set to 0 is complete overkill. Keep it simple, keep it descriptive, and keep it concise. And obviously this also goes for both classes and functions and anything else you're naming. If you create a function that multiplies something, you're not going to want to name it m. It's a magic name which will require you to actually read the function or its documentation to understand what it does. But if you are an adult, I recommend naming it something nice, such as multiply. And then obviously you can add whatever variables or whatever arguments you want to multiply. Moving on to good practice number 2, annotating your code with types. But first I want to mention that annotating your code in Python is completely optional, and it's a tool that's used for the developer to catch mistakes early on in their program if they choose to use a static type checker. Also, most modern code editors are going to help you catch mistakes before you even run your code, which is very useful. And if you've been following my channel, you'll probably have noticed that I use type annotations everywhere. Anyway, let's get started with an example. Here we have a number which we're going to declare to be of type integer. Here we're giving it the type of integer, or we're telling Python that we want this to be an integer. And for whatever reason, maybe it's 3 in the morning, we give it the string value of 10, which in our head is an integer. 10 is an integer, but obviously here we assigned it a string. Now, if we were to run this, it's going to run perfectly fine. Nothing's going to change in the execution of our program. But one thing you might have noticed is that we got some syntax highlighting that is warning us that we're giving this the wrong type, and that can lead us to breaking our program if we're not careful. So type annotations will not prevent your code from executing. It's only going to give us context or give our code editors context based on the types that we are working with. Now, if you were to pip install mypy, which is a static type checker, and you were to run mypy on your current file, which in this case is main.py, mypy is going to scan your current file and it's going to tell you exactly where something did not add up. And here it's telling us that on line 1 we have an incompatible type. And to fix it, we just give it the correct type, such as 10, and we can choose to run mypy again. And this time it's going to run perfectly fine because all the logic in our program makes sense. Another example could be you having a set of integers. So set of type integer. And here you're typing in some integers such as 1, 2, and 3. And out of nowhere, you decide to insert 4.5. 4.5 is a float, and that can easily ruin our program or prevent our program from functioning normally if you use a float in a place that's expecting an integer. Now, if you have the mypy plugin, chances are you're going to see this syntax highlighting. In PyCharm, you can find it in the plugin store. Just type in mypy and you're going to find the plugin which allows you to actually see this highlighting. Otherwise, you're going to have to run your static type checker, So here we're typing in mypy main.py, and it's going to tell us that we have an error for argument 4 in our set on line 1. And to fix that, we either have to remove it or convert it to an integer. But let's look at a better use case. So what we're going to do next is create a function called greet. And it's going to take a greeting of type string and some people of type list of string. And we will return none because we are only executing code here. If we're going to return a type, add the return type. Otherwise, we're just going to specify none. Next, for person in people, we're going to print the greeting, comma, person, exclamation mark. And just to run it, we're going to type in greet, ciao, and we're going to insert a list of people, such as Bob, Luigi, and this time Simon. Now, if we were to run this, you'll see it's going to greet all those people. But what was the point of adding those type annotations? Well, here we get several benefits from adding those type annotations. One is we know exactly what we're inserting here. We know that people should be a list of type string, which means that if we were to type in 1, 2, 3, technically this would work, but we would not be happy with the output because we're expecting names of people. Or also for the greeting, if we were to add something such as a boolean, we would get some syntax highlighting, and mypy would not be happy with that because we're inserting a type which should not be compatible with our function. And it might work, but in other cases, it's probably going to raise an exception. Also, on top of all of this, we also get better context actions based on our code editors. For example, here we defined greeting to be of type string, which means we can use dot notation, and it's going to help us out. It's going to give us all these string methods for greeting. Without these type annotations, and without further context, you'll notice that we're not going to get any context actions, which for people like me can easily lead to a mistake, such as capitalize. If I write it with an S, that's not going to work at all, because obviously in programming we follow most American standards of spelling, so you would have to type in capitalize, and then we'd have to do that. So this time we can put Bob with a lowercase, run it, and it will run fine. With the context actions, I don't have to worry about that, which is what I prefer in most cases. I like making programming as simple as possible for myself. So if I have the option to use dot notation and use autocomplete, I will go for that because that minimizes all the typos that I can possibly make. Now I'm not going to be silly and type capitalize with an S. And that's all because now we have context actions. We know that that's an incompatible type with string. Or, I mean, this method doesn't exist with string. Once again, if we were to remove that, we wouldn't get any warnings because Python has no idea what we're trying to do there. So capitalize could be a method that works, but it also could be completely random. Up next, we have good practice number 3. And for this example, I'm going to paste in this function, which passes a European date. And I'm going to explain what all of this does in just a moment, but we're going to skip to this bottom section right here, where we insert a European date. And what we want to do is extract the information from it. And by European date, I mean we have the day first, the month second, and the year third, which means that once we enter this string and we print the date, the past European date, we're going to get each part back in the form of a dictionary. Anyway, the focus of this good practice is going to be the usage of comments. A lot of people on the internet and a lot of professionals are going to state that good code should explain itself, which is the most ideal case you can have in programming, writing clean code. Unfortunately, on the internet, you're going to find a lot of rubbish, or even at your future workplace, you're going to find a lot of rubbish because people are getting paid to make things that actually work. They're not always getting paid to make things look its best, because the reality is a working product is always going to be better than no product at all. So with deadlines, with people being rushed, with people being tired, you're going to see a lot of poorly written code in the world. And my advice for this is that if something isn't clear enough, provide some extra context using comments. It's going to help everybody in the end. You might have to do a little bit of extra reading, but I prefer to do a little bit of extra reading than not understanding the code at all. So what I'm going to do here is add a few comments that I'm going to find useful for the future, because I just wrote this recently, which means it's still fresh in my mind and it's easy for me to read. But there's no guarantee that it's going to be like that in the future. So if you're experienced in programming, this part might seem quite obvious. Here we're splitting the date string every time it runs into a slash. So it's going to extract 25, 10, and 24. If something like that doesn't look obvious to you, add a comment. Say that this will split the date string into parts using the slash symbol separator. If this helps you and other people, go for it. Adding comments that helps you remember what code does is a good practice for yourself, because being able to remember what your code does is much more important than anything else. Also this part here, I mean, we can read the code and we can try to figure it out. If the length of parts is equal to 3, then we can extract the 3 parts of the date. That can seem quite obvious to most, but if it helps you and if it helps other people, add a comment. Make sure the date has the valid amount of parts. And you can also do something such as day, month, and year. Then this is not going to look like magic anymore. And here we can also type in return each part in the form of a dictionary. If these comments will help you remember, go for it. Add them. People who claim that they never add comments because their code is too obvious, I don't trust those people. I don't trust those people at all, because there's always going to be someone who doesn't pay close enough attention, or who's not as experienced, or who just misses it because they are just skimming through it too fast. Making things as obvious as possible is a win for everyone. I mean, it took me maybe 3 seconds extra to write this comment, and it's going to take people 3 seconds extra to read this comment, but if it helps them understand what the code does, it's a good comment. But for this case, I would argue that this is quite redundant, because we are obviously returning a dictionary with the keys being set to each part of the date, and the parts are being extracted from the parts. So we're going to remove that comment for now, and we're going to add a different comment down here, because right now we're just creating a date and calling it. And for me, again, it's quite obvious that I'm testing this function, but for other people, it might not be. So here I'm going to type in example usage, so that other developers will understand that I'm just testing it here. And right now we've only been writing useful comments, but there are going to be cases that you're going to see incredibly useless comments. For example, here we're trying to print the date. So if you were to type in prints the date, this is what's called a redundant comment, because it doesn't add any new information and it doesn't make the intent any more clear. It is extra obvious already that we are printing the date here. There's nothing we have to add here. The rule of thumb is to add a comment if there's some extra context that you want to add to your code, which does not fit in the code itself. It could also be a link to a resource that you're using, or to some external API, or to literally anything that you cannot include in the code itself. Moving on to good practice number 4, docstrings. Up until now, we've been using comments to further inform whoever is using this function in the future about the small sections that might be a bit confusing. Now, while that approach was okay, a better approach here would be to use docstrings, because a docstring is going to tell the user exactly how the function works. And to create a docstring, you just need to type in triple quotation marks at the top of your function declaration. So here we have 3 quotation marks, we tap on enter, and if you're using PyCharm, it's probably going to give you some Sphinx markup. But to keep it simple, this is the information that we have in our function signature. So right now I'm going to remove the return type. Here we would specify what we're returning, which is a dictionary that contains the day, the month, and the year with its parts. I'm not going to write all of that, but that's where you would add that description. The parameter would be a date string in the format of month or day, month, and year. We can add slashes there. And the type of date string is going to be of type string, obviously. And here you would write all the relevant information to the function, how the user should expect to use it, what all of this actually does. But for now, I'm just going to type in description just to fill in the blank for this very moment. Because what I want to show you next is that the next time we actually hover over the parseState function, we're going to see all of the information that we specified. The description, the parameters, which is a date string, and what it returns. Now, this is a very poorly written docstring. I didn't really give this any useful information. Ideally, your docstring will look a little bit more like this. And I know this is going to appear quite small on your screen, so I'm going to read it. But the description is, we have a function now that passes a European formatted date string following this format into a dictionary with day, month, and year as integers. This function splits the input date string by the slash character and expects it to contain 3 parts: a day, a month, and a year in that order. It then converts these parts into integers and returns them in a dictionary. Then we have the Sphinx markup, so we have a parameter called dateString, which contains a date string in the format of date, month, and year. Then we have the type, which is of type string. It returns a dictionary with the keys of day, month, and year containing the respective integer values. And then it raises a value error. So if it doesn't match our specifications, that value error is going to be raised. And something else you can do in the future is add an example case in the docstring so that whoever is using this function can even test it before they run it to see what the output will look like. This is all incredibly useful information for the function. And once again, if we were to hover over that function, we would get all of that data back. And I would like to argue that writing documentation is one of the most important parts of programming. Most of the errors you'll see today that come from developers all originate from poorly written documentation. Even I've written a lot of bad code due to poorly written documentation because I had no idea what was going on. I used the function to the best of my ability, but no one on the internet explained how it really should have been used. If you're creating something that's going to be used by a lot of people, I absolutely recommend you write a descriptive docstring, because then no one's going to guess how your function works and everything's going to be written right there. There's not going to be any arguments of what the best way to use it will be, because you've explained exactly what it does and what it should return. So I absolutely recommend you add docstrings to all of your functions. The only exception being that if you're writing a throwaway script, which means a script you're only going to run once in your life, you're probably not going to want to waste your time with all of this writing. And that's quite understandable. But if it's something you think that a lot of people in the future are going to be using, or even yourself, adding this information is vital. And finally, let's move on to the 5th good practice of the day, which will also be the final good practice of the day. And for this example, we're going to create a module. And to do so, we're going to create a new Python file, and we're going to call it calculator. And let's just ignore the fact that we have a math module in Python. We're going to write the functionality here from scratch, because our calculations are much better. I'm making that up, but let's just pretend that's the case. So here we're going to create something called add, which is going to take an arbitrary amount of numbers. So here we're inserting args by adding the asterisk. And that's going to be of type float. All of these arguments are going to be of type float, and they're going to return to us a float. Now here we want to return the sum of these numbers. Obviously, we could just use sum from the start, but in our module, we're going to pretend we had a different implementation. But next, to test it out, we're going to print add, and we're going to add all the numbers that we have in our heart, such as 40, 20, and 100. Very good numbers. Now let's right click and run this calculator module. And what you should notice in the console is that we're going to get the sum of all these numbers. So the module works perfectly fine, which means now if we have some other script and we want to use this functionality, we can do so by importing calculator and printing calculator.add. And here we'll add the numbers of 1, 2, 3, and 4. So the sum of these numbers should obviously be 10. And when we run this script, we will get 10 back, but something else has happened. We also got 160 back, which can lead to a lot of confusion because in this script, all we did is a single operation that returns the integer value of 10. We don't have anything on this screen that returns 160. And unfortunately, this is the result of poorly written code because we created a module and we tested the module in a very silly way. And one thing you should know is that once you import a module, all the code in the module gets run, which means the print statement was executed as soon as we imported this module, which is not what we want. But something else that we don't want to do is comment this out each time we want to test this function, because now we have to go back, we run this, it works fine, but maybe it doesn't, so we go back, we uncomment this, we change it, and then we comment it again. It's annoying, it's a lot of work. When what we could have done instead is use the if name is equal to main check. And this is a fundamental part of learning Python, and I absolutely recommend you use this everywhere. And I'm going to be using what they call a live template in PyCharm, which means I can just type in name, for example, and it's going to fill in the blank. But if name is equal to main looks as follows. What we have here is a dunder name is equal to the string of dunder main. So if this is the case, we're going to run this code. And to explain what this does in simple words, when you run a script directly, the script is named to main. So calculator in this case will be main if we run the script directly. And to run it directly, you right click on it and you tap on run. Now we are running this script directly, which means this code will be executed because the name is main. Don't be fooled by the file that is called main. That's not what it's looking for. It's looking for the file that you are currently running. So main in this case is going to be our module, the one that we're currently running. And again, this will only run if we run this file directly, which means that we can now run main and we're not going to get that silly output because calculator is not main, which means this will not run when we import it because we are not running that file directly. And what's beautiful about that is that we can now test this function as much as we want, and this line will only be executed in the current module. So if we tap on run calculator, we'll get 180 this time. Another benefit of having the if name is equal to main check is that it tells the user or the developer which part of the script was made to be run. Now we know exactly without scrolling through the module, which could be huge, where we can actually test its functionality or where we can actually run and use its functionality. So even in our main scripts, you should feel more than free to add an if name is equal to main check, because you might have a lot of code in this file and it might be a very big file, which won't always make it clear where you should run the file. But by adding an if name is equal to main check, in PyCharm, you're going to get a very nice green arrow, which I use a lot. And that tells us exactly where it should be run and if the file should be run at all. A module without this was probably not made to be run at all. It was only made to be imported. But with this check, we know that we can run this file directly if we want to. So yeah, always remember to use the if name is equal to main check when you have the chance, because it will save you from these silly mistakes that occur when you import modules. But yeah, that just about covers everything I wanted to talk about in today's video. Do let me know in the comment section down below what you thought about all of this. But otherwise, as always, thanks for watching and I'll see you in the next video.